Hello everyone, it's Mimi here. BMS working in the NHS. And today's video will be about tissue processing and embedding, which is part of the IBMS specialist portfolio in cellular pathology. So, just a quick introduction to this video. It will be short and sweet, I promise. It will be focused on the fourth subsection of the specialist portfolio called tissue processing and embedding. I will discuss knowledge requirements, competence requirements, reflective statement, evidence of achievement, Q&A suggestions, possible evidence ideas, and some helpful tips to make your portfolio really good. With all that said, I hope you will enjoy the content of my video and I hope you will learn a lot. So let's dive into the third subsection of the first section: tissue preparation techniques, tissue processing and embedding. Knowledge requirement is what it is expected of you to know and understand to demonstrate your knowledge is at the specialist level. Think about what knowledge you had as a Band 5 BMS. How would that differ to the knowledge as a Band 6 BMS? That specialist level of knowledge would allow you to troubleshoot, problem solve, verify, validate, help others and maintain high-quality service. Let's have a look at the first knowledge requirement, which is for you to know the principles and practice of paraffin wax tissue processing for a range of tissues. What is processing and what are its principles? How do you process samples in your laboratory? Do you process all samples in the same way in your laboratory? How can processing affect product, stain slide? What is the difference between the old-style processors, the new generation rapid automated processors such as X120 Sakura, Leica Histo-Core Polaris 3, Milestone Pathos, COS, Magnus, and microwave-assisted models, and what are their limitations? What could happen to the sample if the processing was directly? Consider fixation, dehydration, clearing, wax infiltration, reagents used, vacuum, temperature, agitation, conventional versus rapid versus microwave processing, limitations of processing, suitability of wax processing, and so on. The second knowledge requirement is for you to know the influence of processing schedules on the quality of sample preservation for subsequent analysis. What processing schedules do you use in your lab, and why? Consider this from the tissue type point of view, like fatty or routine tissue, from the sample size point of view like biopsy or resection, from the instrument type point of view like conventional, automated and microwave-assisted processors, effects of processing on subsequent analysis, consequences of poor processing. Ask yourself, for which samples would you use each processing schedule and why? How do processing schedules affect the quality of the sample preservation for subsequent analysis like H&E, IHC, or molecular testing? What would happen if a wrong schedule was selected for the wrong type of tissue? Consider what would happen if biopsies were processed on the extended or fatty schedule, or if fatty tissue was processed on a rapid schedule suitable only for small biopsies. The third knowledge requirement is for you to know relative merits of different processing reagents and schedules. What reagents do you use during the processing in your lab, and why? What do these reagents do during the processing schedule? What are the risks and hazards associated with those reagents? What are their limitations? Do those processing reagents differ in different processing schedules? Do processing reagents differ between the old-school conventional, new generation rapid automated processors and microwave-assisted processors? If so, why and how do they differ? Consider common reagents used during processing, types of reagents that can also be used during processing, alternatives, pros and cons of used reagents, health and safety risks associated with those reagents, limitations of reagents, suitability of reagents, variation of reagents used, possible substitutes for routinely used reagents, conventional versus automated versus microwave processing, and so on. The fourth knowledge requirement is for you to know the effects of heat, pressure, and vacuum on tissue processing times and tissue morphology. What are the effects of heat, pressure, and vacuum on tissue processing and tissue morphology? Can you name advantages and disadvantages for each? How would you optimize tissue processing in relation to pressure and vacuum? What can heat, pressure, and vacuum do to the tissue if applied incorrectly? Consider how heat, pressure, and vacuum affect the overall speed of processing, how they can affect tissue morphology and lead to shrinkage, hardening, cellular damage, loss of detail, altered staining properties, protein coagulation, pore infiltration, soft mushy tissue, compression, distortion, crush artifacts, and so on. The fifth knowledge requirement is for you to know principles and practice of resin processing. What is resin processing and when would you use it over the traditional wax processing? What are the key steps of resin processing and how do they differ from the wax processing? What are the advantages and disadvantages of resin processing? What types of resins can you use during resin processing? Consider when resin processing would be used. Think of the sample types where resin processing would be used. Reagents that are used during resin processing, advantages of superior morphology resin processing offers, section thickness, specialized application of resin processing for EM, general steps of resin processing like fixation, dehydration, infiltration, embedding, polymerization, types of resins used, possible advantages and disadvantages when compared to routine FFPE processing in histology like technical complexity, staining approach, cost, time, safety, and so on. The sixth knowledge requirement is for you to know principles and practice of a range of tissue embedding techniques, and potential errors that may arise. What is embedding and what embedding techniques are used in your laboratory? Consider wax, frozens, resin, automated embedding, their principles and practice. What errors may happen during embedding and how would you resolve them? Consider pore processing, orientation, air bubbles, overheating, cooling, cross-contamination. The seventh knowledge requirement is for you to know correct orientation for embedding a range of tissues. What is orientation and why is it important? What could happen if tissue was not correctly orientated during the embedding? Do you use special instructions during embedding for certain specimens in your lab? If so, what are those and why used? What would happen if they were not used correctly? What tissues require specific orientation and why? Consider the impact of embedding on the sample and the patient, the importance of correct orientation, the impact of poor orientation, special instructions, sample types that require orientation during embedding, method for orientation, way of communication for orientation. Also consider traceability, training, and competency. The eighth knowledge requirement is for you to know risks and hazards associated with the use and disposal of processing reagents. What are the risks and hazards associated with the use and disposal of processing reagents? How would you mitigate those risks and hazards? Consider health hazards, safety hazards, environmental hazards associated with reagents used, COSH, SOPs, PPE, regulatory bodies, waste segregation, risk assessments, RITR, HSE, preventative measures and so on. The ninth knowledge requirement is for you to know risks and hazards associated with the use and disposal of embedding media. Similarly to the previous requirement. What embedding media do you use in your laboratory? What are the risks and hazards associated with the use and disposal of embedding media? How would you mitigate those risks and hazards? Consider health hazards, safety hazards, environmental hazards, COSH, SOPs, PPE, regulatory bodies, waste segregation, risk assessments, RITR, HSE, preventative measures and so on. Competence requirement is basically a combination of knowledge, skills, and experience one needs to perform a job to a satisfactory standard and level. Your chosen evidence should demonstrate these competence requirements. The following competence requirements need to be met for this section. The first competence requirement is for you to prepare tissues prior to processing. How do you prepare tissue for processing? Consider fixation, dissection, inking, inflating tissue like lungs, sample type, sample size, and so on. The second competence requirement is for you to evaluate, select, and use the appropriate processing protocol for a range of samples, maintaining audit trail records, as appropriate. How many processing schedules does your lab have? Why do you use multiple processing schedules? What could happen if tissue was processed using incorrect processing schedule and why? How would you resolve processing issues? How do you maintain audit trail record for processing? Consider sample type, sample size, processing schedule, processing type, traceability, record keeping, and so on. The third competence requirement is for you to select and use the appropriate processing reagents. What processing reagents do you use in your lab? Why are those used? What do they do during processing? What would happen if processing reagents were used incorrectly? Consider common versus alternative reagents, reagents used during conventional, rapid or microwave-assisted processing, FFPE versus resin processing, health and safety hazards associated with reagents used, their advantages and disadvantages, and so on. The fourth competence requirement is for you to perform processing and embedding procedures on a range of tissues. Do you routinely perform processing and embedding on a range of tissues? How do you perform processing and embedding? Consider SOPs, methods used, training, competency, types of samples, and so on. The fifth competence requirement is for you to select and use the appropriate embedding medium. What embedding medium do you use in your laboratory? Why and when do you use it? What embedding medium would you use for different samples? Are there any other embedding media that can be used in histology? If yes, when would you use them? Consider common and alternative embedding media, conventional versus automated embedding, frozen section versus FFPE versus resin embedding, health and safety hazards associated with embedding media, possible advantages and disadvantages of embedding media. The sixth competence requirement is for you to use a range of automated tissue processors. What tissue processors do you use in your laboratory? What is the difference between them? Are there any other types of tissue processors? Consider conventional, automated, and microwave-assisted processing, types of samples each can be used for, size of samples, and so on. Try to use examples from your practice. The seventh competence requirement is for you to correctly orientate a range of tissues when embedding. Can you correctly orientate a range of tissues when embedding? What tissue types require special attention during embedding and why? Consider SOPs, methodology used, training, competence, sample types that require orientation, communication regarding orientation, and so on. The eighth competence requirement is for you to perform basic maintenance and troubleshooting of tissue processing and embedding equipment. What errors have you experienced with processing and embedding equipment in your practice? Do you know how to troubleshoot processing and embedding equipment? How often is the maintenance of processing and embedding equipment performed? Where is this recorded? How would you verify the equipment is fit for use following service or repair? Where is this recorded? Consider daily, weekly, monthly, and annual maintenance, need for servicing, potential sources of problems with equipment, corrective and preventive actions that can be introduced to prevent problems, record keeping, verification, validation, and so on. The ninth competence requirement is for you to troubleshoot problems which may arise, including root cause analysis, as appropriate. What problems have you come across when it comes to tissue processing and embedding? Why did they occur? How did you resolve them and what did you learn from them? Where did you record your actions? Consider potential problems you may encounter, corrective actions taken, preventive actions, record keeping, verification and validation, and so on. Each section also contains reflective statement which is asking you, the candidate, to summarize your role in the laboratory in the context with each section. When you complete all the subsections within this section, you will be required to write a reflective statement. You also needs to write a personal reflection on your training and why you chose your evidence. To prepare for that, write a smaller reflective statement for each subsection. What is your role in context of this subsection within the laboratory? What does your evidence demonstrate? Also write a smaller justification as to why you chose your evidence for this subsection. Also write what was your training like when it comes to this subsection. Writing a smaller reflective statement at the end of each subsection will then make it much easier at the end of the section. Each subsection also has evidence of achievement. This is a part where your training officer signs you off as competent and fit to practice as a BMS at the specialist level. Training officer will confirm that you can work in accordance with local SOPs relevant to this section. They will also confirm that you have answered questions set by them to test knowledge and skills relevant to this section. And they will confirm that your chosen evidence demonstrates your competence relevant to this section. You will need to be signed off as competent by internal assessor for this section. This can be your training officer, senior BMS overseeing this section, or a training lead. Questions should be set by the training officer. They need to be based around the knowledge requirements, relevant for each subsection. They should allow the candidate to demonstrate their understanding in each subsection. The questions should be specific and relevant to the candidate's in-house practice. They should also allow the candidate to demonstrate their specialist knowledge. If you would like to see specific example questions, please have a look at the video for trainers. Link will be included in the video description. These are some ideas for supportive evidence you will have to submit to demonstrate your competence in this area. Some more ideas for supportive evidence to demonstrate your competence in this area. I would also like to share with you some helpful tips that can make your portfolio look really good. Try to present the information in various formats such as tables, pictures, photographs, diagrams, flowcharts, graphs, or even videos, if you can. This nicely breaks down a lot of text that is usually present in specialist portfolios. Try to make it a little bit more interesting to the reader, which will be your training officer and eventually the assessor. Try to put yourself in their shoes. How would you like to read hundreds of pages of plain text? There is a saying I really like, and it goes like this: a picture is worth 1,000 words. I will make a video. I will share with you my evidence I used for my portfolio back in the day. Hopefully that will help. Also try to use various types of evidence, not just one type, like case studies for each subsection. You could use experiments, case studies, annotated results, annotated photographs of you performing tasks, evidence of troubleshooting, annotated EQA results, nonconformances, validation and verification as comparisons of different approaches and their pros and cons, control material production, certificates of course attendance with reflective statements, annotated images or charts, and so on. Try to bring in your personality. Think about the ways you like to learn best. If you like experimenting, perform experiments. Like troubleshooting, perform troubleshooting. Choose something that demonstrates your understanding, knowledge, skills, and how you apply this in your practice. And one more thing, keep the competence requirements in mind when you selecting your evidence. Good evidence will tick off several requirements. And this brings me to the end of today's video. Hopefully you now have a better understanding about the knowledge and competence requirement for tissue processing and embedding subsection. And I hope you also have a better idea what evidence you can choose to demonstrate your competence. And my final take-home message? Keep those requirements in mind when answering questions and selecting your evidence. Bye for now.